Hello, this is the last section for this book. Some of you have this last chunk in your packet, so it's the grand finale of the packet. And for others of you, you have a separate handout with just this material in it. So we're going to sketch graphs that show the situation here. All right, we have three stories based on this lovely little situation. So there's a bus tour, and they have some time to do whatever they want with. So the people break into three groups. I know that you can read that. I don't want to bore you. So the first group goes for an early lunch. The furnace breaks. The restaurant gets cold. They leave. So early lunch, restaurant cools, and they leave. So if you're thinking about this situation, if you're thinking about a graph, what would be the label on the x-axis? What are we in charge of? What's the independent variable? And that is time. And then what would the y be? Depending on the time, you could graph this with temperature, or you could do time with people in the restaurant. So if you're graphing time and temperature, it'll be temperature in the restaurant. And we'll label this group 1 because this is the first group. So the restaurant was probably hanging out pretty warm, and then it steadily decreased until it reached the outside temperature. If you're graphing people, there might have been more and more people coming in, and then it got cold, and all of a sudden everybody sort of left. You could do temperature with people also. Just remember that x-axis is the variable that you are in charge of, the independent variable. Okay, so the next one is a parasailing group, and this person is pulled by the boat. And then her parachute opens up and she soars into the air. And then she gradually descends and lands on a platform at the back of the boat. Okay, so if we're going to do a graph of this, just a rough sketch of what this would look like, again, we are in charge of time. And probably it would make the most sense to do height, because if you're parasailing, that's what's changing here. So she's pulled along by the boat, so it seems like her height would be the same. She's not changing height. She's not changing height. And then she's probably, when you're parasailing, do you start in the water? Do you start in the boat? I don't know. I'm not a parasailer. I need to try this. So what it says is maybe she's going to the parachute opens and she soars into the air. So she's probably going into the air quicker and quicker and quicker, which would be a curve like that. And then she probably gets to as high as she can go. So now she's going to hang up there, seeing the beauty. And then she's going to descend gradually. So gradually, it might be like a linear descent at a constant rate. It might just be a slow descend, super slow. And then she lands on the boat and hangs out. Something like that. It might be a curve, like a slowing down descend, gradual descend, whatever you think it would be. And the third group, and our number for this is 2, don't forget titles, are renting bicycles, a steady pace. And that's it. So they're just going at a steady pace. So again, you're in charge of time. And you could put the pace that they're going. So if they're going at a steady pace, that means they're going to well, they're going to start from stopped position, so they're going to increase to their pace, and they're just going to stay the same. They're at their steady pace. So over time, they maintain the same speed, and then they probably stop. You could do distance traveled with time. So the distance traveled would continue forever, because even when you get back to the starting amount, you've still traveled more and more distance. If they're at a steady pace, the distance would be steady. All right, so there's some matching. And it says, number 1, what does that look like it matches? And that looks like the parachuter. And number 2 looks like it matches the restaurant. That's number 1, because all the people leave. And this one is where she's hanging out in the boat or in the water, however that works, soars up into the air, and then decreases at a steady pace. Very close to what we drew. Nice work. And then the third one is draw the last one and explain it. So I'm going to just go back to this and explain it. We have 2 different things to explain. So the first one is if biking at steady pace, distance travels increases at a steady pace. And this is a stopped. This is your steady pace. And then this is slowing down and stopping. This would be speeding up to your steady pace, because you have to get to your steady pace. So we're going to make up a story about a cyclist that could be modeled by the graphs. And then we're going to show where they're traveling the fastest and explain how you know. So this question is with distance. So as you can see from here to here, the distance is constantly increasing. So this part, the person is biking at a steady pace, or cycling. All right, now it looks like to me that it's actually going down a tiny bit. If you think it's flat, then they would have stopped there. If you think it's going down, they might have dropped something and turned around. To me, it looks like it's going down a tiny bit, so maybe they turned around looking for, maybe they lost a tooth. And then, right here, they're really speeding up faster and faster and faster. Say they must have found their tooth. And they're speeding up because their distance is rapidly increasing. So found and speed up to meet with group. Assuming that the group continued their pace. That would kind of make sense, and then they would meet right here. All right, the second one. This person is gaining distance pretty fast. So, that was the second question. This is where they're traveling the fastest, because it's the steepest slope. These graphs are kind of chunked up into 3 different parts. There's like 3 different graphs within this. There's a graph here, then there's a graph here, and then there's this third little piece. These are actually called piecewise graphs, and you need to actually write equations individually for them. You can't write like one big equation for these graphs in pieces. So this is the steepest, which is the fastest, because it's the most distance in the least amount of time. So this person must have been very gung-ho to start. So they're biking, quickly at a steady pace because it's a line. And then it flattens out, so it looks like they need to take a break, maybe get some water. So they stopped. They have not increased distance. Maybe drinking water. This is a really exciting story. And then they're going to continue their exciting cycle, but they're going a little bit slower because it's not as steep as this. They're traveling less distance in more time. So continue at slower, steady pace. Okay, we're going to write a little story about this situation, and there's multiple of these with buses and cars. So in this, the bus and the car are traveling the same distance because it's their parallel lines over time. So the bus is ahead of the car. See how its distance is farther? The bus is ahead of the car, and it stays ahead of the car. So they must be traveling the same speed. And they say the same distance apart. Okay, in the second one, the car is behind the bus, just like the first one. And it's traveling faster because it's a steeper line. Okay, so that's the car. The car passes the bus. See, it passes the bus right here. So the car passes the bus and continues its constant speed. And the slower traveling bus becomes a flat line here. This is where it stops. So the slower bus stops. Alright, why don't you hit pause and see if you can make a story for these four, and when you're feeling satisfied, hit play and see if your story is similar to mine. Okay, you are ready to check. Car behind bus. Car faster than bus. Car passes bus. And it continues at its steady pace. The bus is curving like this. So it's getting slower and slower and slower until it stops. Bus slowing down. And then it stops. There's no intervals, so we have no idea if this is just like a few minutes or a few hours, so you can make up whatever story you like. Okay, the car is behind the bus. They're both traveling the same speed, and they're staying the same distance apart. And then they both stop. Maybe it's like a stoplight, or maybe the bus stops and has a stop sign because they're letting kids out. Okay, this one looks super fun. I'm so blessed to have the vision to see this. So the car is behind the bus, traveling faster because it's steeper. right here, the car passes the bus. I'm going to put slower moving bus. Then, right here, the car stops. Maybe they got a ticket for going too fast. Maybe they stopped to help a duck cross the street. So while the car is stopped, the bus, right here, at its steady pace, passes the car. Then the bus stops at a very similar place to the car. And then the car continues at a slower pace. This is steeper, so this is the fastest spot. And then the car passes the bus. And the last one, they both stay stopped. There is no spot where they're traveling fast at all. They're both stopped. They're at the same distance, so there's nothing to circle there. Did we circle the fastest part of... we did not. So the fastest part of C is this constant line. And the fastest part is this constant line. I feel like we did in the first two. No, this is the fastest part. This whole thing. You're just looking for the steepest line, and this whole thing is the fastest. The steepest line. Because the question said... that was the other problem. Okay, well, hey, we just did a little extra. That's very exciting. Oh, letter B. Which does it reach the greatest speed? And then letter C is where does the bus reach the greatest speed? So B's the car, C's the bus. So I actually just sort of did that with you. So the greatest speed for the car is the steepest line. Look at B. B's pretty steep there. B is steeper than C. Is E steeper than B? That's the question. E... Just doing an eyeball look here. I think E might be the steepest. If you think B is the steepest, put B. It really doesn't matter. That's where I think the car's the fastest, because it's the steepest line. It's going to be the biggest slope. And then the bus is the fastest. Okay, letter B, it's kind of swooping up there. Oh, that's... Oh, you can tell I don't feel very good. Okay, so the second one is really not that fast. That's slowing. The bus is also the fastest in E right here. I think this is the steepest part for the bus. That's where the bus's slope is the biggest number. So they're both in E. All right, we will work more with analyzing graphs like this the next time I am so blessed to see you. So I can't wait for that moment. Have a lovely evening. Smile. Be healthy.